All right. Thank you for joining me on the probably last slot of the conference. And you are all Java developers, so I hope so. Welcome to Build. This session, we're going to talk about running Java applications on Azure. My name is Bruno Borges. I'm part of the Java Cloud Developer Advocacy team. We help Microsoft engineering team deliver a good developer experience based on Java developer expectations. And we also provide information to developers who are using Azure so they can know more about other services and take full advantage of the services that they have at hand. If you want to follow for more of that information, you can check my Medium account or Twitter. Probably Twitter is better. If there's something interesting, then you go from there to Medium. Or if you actually have a more in-depth question, feel free to email me at my bruno.borges@microsoft.com. I've been working with Java for more than 16 years. It's like since 2001, but when you started, don't count that exactly. I was a student. And been doing a lot of talks and writing server-side code most of the time. In the past, I used to work for enterprise companies, and the trend for Java ecosystem is still strong in corporate places where 90% of big companies are using Java. And it's an interesting thing to look at when most of these companies now want to come to the cloud and they are looking for compliance, they're looking for certifications. And Azure is a really good cloud from a Java perspective in the enterprise world where you can feel safe in a trusted cloud such as Azure. Some examples of customers. If you go to customers.microsoft.com, you can check out some stories that customers are running Java on Azure and how. Some examples that we have here, Tracon Electric, they use Tomcat with Postgres. Stanley using Spring and Apache Kafka with CI/CD using Jenkins. And Jenkins is a very interesting story on Azure where we have VSTS, but you still can combine VSTS and Jenkins. SCSK running JBoss and OpenShift, it's an interesting story because yesterday we just announced at Red Hat Summit that's happening in San Francisco this week, where we are now running a managed OpenShift service on Azure. So you can go to your CLI and say AZ OpenShift create, and then you have your OpenShift environment. And American Corporation is running Spring on top of Pivotal Cloud Foundry. It's another multi-cloud solution in our partnership with Pivotal that we deliver on Azure very seamlessly for developers. When we talk about deployment choices in the cloud, and we look at these customers and how they're bringing their applications to Azure, we've identified mainly 4 ways that Java applications are being executed in this environment. The most traditional way is simply using VMs. And that's been used for many years for many companies. And I would say many companies would prefer to just move those VMs into the cloud as is. And that's safe because they don't have to modernize applications. They don't have to recreate everything from scratch. They just take advantage of that scalability in the cloud without making any changes. We have some partners, Red Hat, Oracle, IBM, Terraform, CloudBees, that help us or Zoho for the JVM, that help us in deliver their products in a very good descriptive way on top of Azure Compute. Some of the services that we see being used are Azure Migrate Service that can assess the VMs that you have on your environment and help you in that migration. And then you take that information and you combine with Azure Site Recovery, and then you can export, bring those VMs, especially VMware, into Azure as is. There's another service that is very useful, the Azure Database Migration Service, most of these workloads, Java workloads, are traditional using relational databases, especially in the enterprise for legacy applications. So when you combine that with Azure Migration Service, it's a pretty good solution to take advantage of the cloud without having to make changes in your application. One interesting service that I like to highlight here is the Azure Dev Test Labs. One thing that they do, that this service allows, is for developers to have an environment, like a VM or a set of VMs, that they can install software, they can use templates, of course, that might simulate a production environment. So that helps them not having to run, let's say, heavy databases in their local computer. They can just use the Dev Test Lab. And the thing is that the cost is way cheaper than the regular VMs for production environment. So it's a good solution to take advantage of the cloud. The other aspect of running applications, and then now we start to modernize our applications, is running containers in Kubernetes. On Azure, we have Azure Kubernetes Service, we have Azure Container Instances, and these are just a few options. You can still do container on top of VMs, of course, but when you have the orchestration out of the box on AKS, or the serverless container approach that ACI delivers, where you just want to run a container, you don't care about the VM either, or even the orchestration. Here's my Docker file, here's my Docker image, I just want to create an instance, and give me a URL. So ACI is really good for that. And Azure Container Registry is where you can publish in a private space your Docker images. And the partnership with Red Hat to bring OpenShift on top of Azure, and behind the scenes we are using lots of containers in Kubernetes. It really helps drive that this deployment choice. Other solutions that we see happening are with Jenkins. Jenkins, they just announced recently Jenkins X. That is Jenkins CI/CD, but you install it on top of Kubernetes, and you can scale all the Jenkins agents. Forgot the terminology, but you can scale out your farm of Jenkins environment easily on AKS. The third option is, of course, I don't even care about containers. I don't care about VMs. I just want to use my multi-cloud environment. So I have Pivotal Cloud Foundry or I have OpenShift, and I want to span that even across different data centers or even across 2 or more clouds. So that's a solution that it also works really well. Some of the services that you might find in this case are, again, AKS and VMs. Azure Storage, there's a lot of usage here. When we talk about Cloud Foundry and how the Open Service Broker API might be used and extended through PCF, some services such as Azure Storage and Azure Cosmos DB show up. And of course, security. Some of the customers that you see at the bottom are using a mix of these services and these technologies that we see at the top. Finally, serverless. For a brand new application, or sometimes even for an existing application that you want to start breaking it down, you might have a functionality of your application that you want to pull over from a monolithic application and just turn into a function, deploy it on a service such as Azure Functions, and easily integrate with other services. It's a deployment choice that we see happening. One of the companies that we see adopting this now is Starbucks. We saw that at a keynote. They are using Azure Functions to start scaling their applications easier and faster. And for the Java developer, we have that first-class support on Azure Functions. We have that first-class support even for Pivotal Spring Cloud Function, which is a framework as part of the Spring solution that helps the Spring developers take an existing Spring boot code and turn that into a function. And that can be deployed easily on Azure or even on other clouds. So we do that kind of work with those partners to make sure that all these forward deployment options are easily achievable on Azure. So you don't have to use Microsoft technology end to end. If you're already working with these companies, we've established partnership and integration. So if you need to bring that application to here, it becomes much easier. So when you get into the details of the sort of applications that we support, the sort of partners that we work with, we start to map or have a landscape of all the technology that we support on Azure, either directly or through a partnership. First of all, Linux. Most of the Java workloads that we see are running on Linux. And knowing that more than 40% of the workloads on Azure are already Linux, that makes companies, Java shops, more comfortable in considering bringing their workloads into Azure. So partnership, especially with Red Hat, to provide support. You don't need to have a separate contract, commercial support with Red Hat. If you're running Red Hat Linux on Azure, you open a ticket with Microsoft, and you get that support from Red Hat directly. Cloud automation. We established great partnership with Terraform and also Red Hat, who manages the Ansible project. So if you want to automate, lots of extensions, lots of plugins for these two frameworks. So if you already have something, you just change your target and you have it created on Azure. Kubernetes, Microsoft is a huge contributor to the Kubernetes project, and all of the Docker containers, all the containers run on top of Docker. And I mentioned Pivotal, Cloud Foundry, and OpenShift as a multi-cloud platform solution. And now we get into the JVM and frameworks and runtimes. I mentioned Spring Boot already. And the other thing that we also use a lot is Tomcat, and most of the Java workloads, especially web apps, are running on Tomcat. I'll mention later a service, and Tomcat is the default option. If you want to create a custom Docker image and use Jetty or any other framework, you can do that. But to facilitate that experience, Tomcat is out of the box. Azul Systems provides a binary of OpenJDK that we use out of the box as well under some of the services. So you might be able to change which version of the JVM, and you also can customize and use Oracle JDK or any other build, or even a custom build that you put in OpenJDK source code and build by yourself if you want. In terms of tools, there is a toolkit for Eclipse. And you know how many companies out there are still using Eclipse, and that's totally fine. They're used to it. Developers are used to it. There's no point in trying to migrate them to another tool. So we really want to deliver the same access, the same experience, and that's why we have the toolkit, the Azure toolkit for Eclipse. Same story with IntelliJ IDE. So customers who already bought a license are using the Ultimate Edition or they're using the Community Edition. They go into the marketplace, install the Azure toolkit for IntelliJ. And finally, VS Code, where we have some plugins for Java. And Maven. All the server-side solutions, all the projects, Maven projects, Java projects are mostly built with Maven. There was a Rebel Labs survey, and more than 80% of the projects are Maven, and the rest is Gradle. And Gradle also takes advantage of the Maven artifacts, but by supporting Maven and having lots of plugins for Maven, we believe that you provide the experience on the developer's local computer, but also allows them to automate in other areas such as Jenkins. And finally, integration with other services, CloudBees again, Jenkins, but also New Relic, Splunk, and GitHub. If you go to VSTS, create a new project, you select GitHub, and it's integrated right off the box. And lastly, open source foundations. Microsoft is a member of Eclipse, and most projects on Eclipse are Java, and the same stuff for Apache Foundation. So we're really building that relationship with not only vendors, but the open source community, and trying to make sure that the Java support on Azure through all this is top class. If you want to try Pivotal Cloud Foundry, you can go to the marketplace, Azure Marketplace, search for Cloud Foundry, and there's a process to create an environment. And it's all documented, and they have blueprints. You can find documentation both on Microsoft website or on Pivotal website. And you can check out and use the trial account and experiment. And what we announced yesterday, the Azure CLI integration for OpenShift. So you can also use Windows servers and Windows containers if you want. Really brand new feature that was just announced. Still not many details, but certainly coming soon. So we talked about some of the third-party technologies that we support and how you can feel comfortable about those bringing those Java workloads into Azure. But what if you just want to start a new project from scratch? How does the Java support on Azure looks like, ignoring all the partnerships that we have, all the support for other tools? So on Azure, 3 services on your left, you can run Java, and we provide everything for you. So Azure Service Fabric, which is very similar to OpenShift and Cloud Foundry. Azure App Service, which we provide the runtime out of the box. You give us the WAR file, and we run it for you on Tomcat. And lastly, Azure Functions. You just write a Java code, you bundle as a zip file from a Maven project, and you deploy it. If you want to store data, I mean, of course, there's a lot of database support, but what if you don't even want to deal with that? So Azure Cosmos DB is a NoSQL solution. There are 2 SDKs. We just announced today the reactive SDK, the asynchronous SDK. They use RxJava for reactive applications. But also exports MongoDB and Cassandra API. So if you have a Java application that is talking to Mongo, you can bring that application, just point to the Cosmos DB IP address, and there you go. Azure Application Insights for telemetry. There are 2 ways that you can pull information from Java applications. One is programmatically. You can get the SDK bundled into your application and trigger events as you wish. But there's also the out-of-the-box agents. So you can indicate on Tomcat, here's my App Insight jar plugin, and the App Insight agent will connect to the Tomcat internal API and export all the information about number of requests, how long they are taking, how many errors, etc. All open source, of course. And beyond that, over 50 services are covered through Java SDKs. Either management SDKs, where you can, I want to create an instance of my database, I want to create a VM, or I want to delete an object on storage. So these are like SDKs that help you manage, but we also have SDKs that are more for integration within the application. So let's say you want to provide security. So you integrate that with the Azure AD. You can use the cognitive service for AI SDKs. So everything is on GitHub, and it's constantly updated because the APIs are always evolving, and you always get the latest through GitHub. And I mean, I mentioned already the Kubernetes and containers, but just to highlight again, container instances, registry, and Kubernetes service. For security AD, most applications are already designed with that in mind. For data storage, all the SQL services and storage. And for messaging and events, 3 services, Event Grid, Event Hub, and Service Bus. So Service Bus is for more the transaction kind of information. Event Hub is for stream of events. So Event Hub today exports the Kafka API. So applications already implemented for Kafka can integrate now with this. This was announced this week. And Event Grid for events that happen in systems, like IoT, for example. Just a reminder that Microsoft SQL Server had open sourced its JDBC driver a couple years ago, and it's the only enterprise database that has not only open sourced the JDBC driver, but the network protocol. It's important to remember that to have a JDBC driver open sourced, you have to know how the network protocol of the database works. So you cannot open source if the network protocol is closed. So when they open source it, they also open sourced the network protocol. The last thing is Microsoft Graph. And this was an interesting case where when we started the Java developer advocacy team, I got a message from a friend who asked, "Hey, do you have an SDK for Java so I can connect with my Outlook 365 and create events in the calendar?" And I was like, "Well, no, not yet. I don't know." So I went to check with the engineering team, and they said, "Yeah, we are announcing the Java SDK in 3 weeks from now." That was like 3 months ago. So now you have a Java SDK that you can integrate with Outlook, SharePoint, Word, Excel, whatever, right? And really use all the Microsoft Graph data and integrate that with your enterprise applications. Yeah, question?
Does that extend to the Graph Security API as well?
If that extends to the Graph Security API, I believe so. I believe so. I will not be 100% sure. I believe so, because it's all the Microsoft Graph API. So all the REST APIs have been exposed through these Java SDK. Okay, so back to databases. Most Java applications, again, using databases, and when you go to the dbengines.com, we look at 9 of the top 10 databases are supported somehow on Azure. So Oracle, we got VM templates. MySQL is a service now. MySQL, Azure database for MySQL. MySQL Server, of course, and Postgres in the same way as MySQL. So basically, Azure will manage database instances of MySQL and Postgres. And you can create those instances with the CLI, and then it's back to normal Java code. You go with the JDBC, open connection, and boom. MongoDB is exposed as an API on Cosmos, but you can also, of course, go to a VM or a Docker container and run Mongo. DB2, we have a VM template just as Oracle. Redis, it's a VM template, but you can also run on a container, and Elasticsearch, same thing. And Cassandra goes back to Cosmos DB that exposes an API, or you can go back to VM and container. Sadly, Microsoft Access is still not supported on Azure. Although we are announcing Microsoft Access, still not on Azure. The next step is, so okay, we got great service, we got great support, great partnership with Java vendors. The Java ecosystem is well covered on Azure, but what about tooling? What if I want to be even more productive, or I want to try something new? VSTS provides that productivity for DevOps and CI/CD. We saw that in the keynote when Donovan showed the creation of a project, and I want to deep dive into that here in front of you. Partnership with CloudBees and JFrog for extensions, but also native Microsoft support for many of the things that we need to do for our Java projects, especially Maven and Docker. On the Visual Studio Code editor, it's funny when we see Red Hat providing the Java language support, but it's Microsoft who implements the debugger for Java applications. So that partnership with Red Hat was really good, and the engineering team continues that, evolving not only the debugger, but also adding more and more extensions for Java and for Spring as well. So recently we announced the Spring Initializer extension for VS Code. So just question, who here does Spring? Okay, so you probably go to start.spring.io to create a sample project and kick off an example or something like that, or even your actual project. So Spring Initializer through VS Code is start.spring.io. You don't have to go to the browser, just go in VS Code, and you select which dependencies you want, and it creates the project already automatically downloads and opens in VS Code. Test Runner. So this is a good extension when you have the at test annotation, and it will give you a hyperlink, a magic hyperlink in the source code, so you can just trigger the unit test through there. Remote function debug. It's an integration that we have, so you can test Azure functions remotely. It's pretty cool. And Pivotal has provided some even more extensions for Spring. Cloud Foundry and BOSH. So you can have from one single environment, you can do everything without having to change to a browser or to a terminal or to another IDE. So I'll try to do these 3 demos and walk you through the details. And if you have any question, if you want to see something, just raise your hand and ask, and I'll navigate through that to that endpoint, and we can see how it works. So let me change to my computer. On slide 6. Okay. So the first, I'll show you a microprofile example using Azure Container Instances. And microprofile is a project as part of the Eclipse Foundation that we are interacting with now after we announced that we want to be part of the Jakarta EE working group. Microsoft wants to contribute with these standards at Eclipse Foundation, making sure that those standards are well supported on Azure, but also contribute with the knowledge that we have in cloud development, container, Kubernetes, et cetera, and provide that back to the open source community. So let's go down to microprofile. So here I have a project that I have 2 projects here, Microprofile Conference and Microprofile Speaker. These are 2 Maven projects, and I will start with the conference. It creates a jar file with Wildfly Swarm. So Wildfly Swarm is a project, it's an implementation of Microprofile provided by Red Hat. Microprofile is this idea of collecting some of the Java EE APIs and deliver a Spring Boot-like experience in writing applications, server-side applications. So you don't want an application server, you don't want all the EE APIs, all you want is a REST endpoint. So there's no need to have a full-fledged Java EE app server. And you want that all bundled in one single jar file. So what we can do here is java -jar and just start the service. And it's already in use. So we're going to change the port number. Yeah, it's already running, that's why. So this is running on my local computer, localhost, and provides me a list of all the sessions. You can see that speakers, it's coming empty, so I don't know who are the speakers of this session, because that information is actually coming from another microservice that is running on this. And you're going to compile it right now. So the reason it's not failing, even though the service is not running, is because on Microprofile, we also have the circuit breaker pattern. So even if it's not there, I'll just show it, it's an empty result. So let's start now. Okay. And now we got all the speakers coming from this other service that is running on port 880. The endpoint is speakers, right? So on your source code, I'll just show you out of curiosity. Let's go to the conference, and let's open Visual Studio Code and navigate to that class, Java session resource. So you got here, get sessions, in the session service. Oop, not this one. Yeah, here. So the speaker client should communicate with the other microservice and check for the list of speakers based on that session. I'll put the URL and I'll put the ID of the session. Hey, give me the speakers of this session. But there is a fallback. The fallback method is get speaker feed fallback, and the fallback is simply no. So you get no speaker at all. Now, as you can see here, the configuration is an environment variable that if it doesn't exist, you use the local host. So that's why this application running on my computer works just fine. Okay, so we got our application working, but how do I deploy this to Azure? So let me show you VSTS, and we'll see how this is working. On VSTS, these two projects are under the same project, because consider it a Maven module project where you have multiple modules. Here are the folders, and each project will create a Docker image, right? And as you can see here, I provide the speaker service by default. Will use the default IP address that Docker runs. If you try this locally, it would also work, these two containers. What I actually want to see is how do I build this so I can release it. So let's go to the CI definition and see how it is configured. So the CI definition is, okay, I got two projects, MicroProfile Conference and MicroProfile Speaker. And each of them are a Maven project. So I'm going to do a clean package. I'm going to copy the jar file. You notice here, because I want to get all of them, simply put. And I'm going to publish these artifacts just because this is like the default template that VSTS provides. What we added here was this. We built the image and we push that to the container registry. Okay? And don't do this, what I did, because the actual execution to create a container on ACI, I did this in the build definition. This was supposed to be on the release definition. So I'm building the application and also releasing at the same time. That's wrong. Just for the purpose of the demo, it's easier this way. So I got my image on my registry, and now I want to publish. So I'm just going to trigger an Azure CLI command, Azure Container Create, and I'll provide all the information about that image that was just created and published on the registry server, and provide the URL. So the interesting thing here is environment variables. The speaker service will be running on these endpoints. So on the internet, these microservice knows where the other microservice is, because I'm not using a service discovery infrastructure here. So I'll just provide it not hard-coded, but a inform to the service where to find the other service. And it's a similar thing for the actual MicroProfile speaker. So this is already live, and we can see that on the service. So we got these speakers, and we got the sessions. So here's the speakers. Okay, so what happens if I kill this instance? Let's go to container instances, and let's kill speaker. It should just work the fallback. Okay, so the instance is out, and I can just come here, and it will take a while because it will try a few times and ask for a timeout. And while this tries, let me check on the other demo that we have, because we are almost done in time. So the other demo is the Spring Boot application. Let's go back to the dashboard. So you saw when Donovan created the DevOps project during the keynote. So I did the same here, and this is the same sample that is created out of the box, and I'll just walk you through what are the elements that this template provides you. So you got the source code, you got the URL, here's the service, the application running. We got VSTS release, and we got application insights configured out of the box. This was something that I'm not sure if Donovan mentioned, but it's something that is providing this template. So let's see how all of this is set up. On VSTS, you got this nice dashboard for the application already, but let's start with the source code of this application. I made one change on this code where I added a custom controller REST endpoint greeting. So whenever I hit /greeting, I will get a JSON, and I have a counter here that will increment for every request. So that is running on my Spring /greeting. Name equals Bruno. And there is a greeting. Okay, so this is, okay. Still running. We'll see how that goes. My Spring, this is the application inside. So whenever I hit a request, it will automatically load this for you. So the nice thing about application inside is that you have those agents that you don't have to write any custom code to integrate. The thing that configures this is on your web XML file. So of course, you have to pull the library on your Maven dependency, but this is all you need. So you basically use a web filter, and it will extract all the requests. And we see all that information coming through here. So let's hit a bunch of requests. Okay. And let's go to live stream. And while this loads, let's check out on something else. Oops. On how do we build this project. So as you can see here, this is a Maven project for a Spring Boot application that deploys on Tomcat. But we want to expose this as a Docker file, as a Docker image. The template will use Docker to actually build your project as well. So you don't use the Maven extension on VSTS, you just use Docker. So that's a nice thing, because you might want to use a different solution later. You don't want to have the Maven build tied into the CI/CD tool that you use, such as VSTS or Jenkins. You're just depending on Docker. So here we have a phase build Docker image. Yeah, question.
So in that case, the building inside of the Docker process.
Correct.
At the time of an emergency scaling, of horizontal scaling, wouldn't that affect the uptime of the additional containers?
So the question is if using a Docker build would affect the build of other containers in those agents.
From the little experience
right?
that I had, it would be better to just put the jar on the Docker image, so you wouldn't waste time by building each of the instances again.
Yes, it is just a template for a Docker-based build, but there are many ways that you can improve this way of building your project. The only advantage that I see, and I think we agree, is this build is agnostic to any CI/CD platform. But if you want to optimize, then you're going to have to find that trade-off. Should I depend more on my CI/CD platform or not, right? So here, for example, when this builds, it will not only pull the Docker image again from Docker Hub for every build, but it will also download all the Maven artifacts all the time, every time, at every build. So let's take a look at that and how it works. So I'm going to trigger a build here. So just to finish, so at the end, it's a Docker image based on Tomcat and runs Spring Boot as a WAR file. And I will trigger a build, and I'll leave it running because it will take time. Because as I mentioned, queue new build, and that's it. And then we'll go back to it later, but just to show you the details, It's waiting for an agent, and as soon there is an agent, it will start building. And here is our telemetry connected to our application live. So let's do some hits again. And we see here 10 requests per second or 15 requests per second, and now process the other ones. So this gets out of the box from application inside, pulling that information from Tomcat, running on app service as a Docker image. Okay, so we are done with that. And here we got our build, Docker-based build. So you see it gets the source code, it builds the image, it will push the image and clean up. So all of this will take some time because, as you will see in the log file, it will download the internet again. I mean, the Maven dependencies. So let's move on to functions. That is the other demo that I want to show you. Yeah, question.
What about the cost of VSTs for what you're showing there?
Pretty much everything on VSTS is free. So the cost for VSTS is free. You have, when you build a project, you get over 200 hours of build for free for every month. So and that uses a form of agents that you're sharing. So if you want to have dedicated agents, which would allow you to make Maven artifacts available offline so you can reuse them at every build, then you have to set up a VM, and that would be have the VM cost. Yes, question?
Isn't it 240 minutes that you get for free build time?
I'm sorry,
I think it's 240 minutes build time that you
240 minutes build time. Maybe that's that. Maybe I got it wrong. I think 200 hours is too much per month. Yeah, thank you. There you go. So let me show you the Azure function for now, because we are almost over. Okay, so I'm on the folder live, and I'm going to create a project. So Maven, Azure Functions provide an archetype for Maven, so you can create a Java function for Azure easily with this skeleton. It will ask for basic stuff like, okay, I got my group ID, my artifact ID will be live function. My snapshot version is, package is this. The name will be live function. West US and resource group. Yep, got it. So I'm going to go into live function, Maven package, Azure Functions, run. What it will do, it will build the project. There's a kind of hello world in this Java code. I'll try to show you quickly. And I also want to run it locally to see how it looks like. And it looks like this. So let me put a name here, and hello Bruno. I can say build, hello build. Okay, so how does this work? Let me open on VS Code. It is a Maven project, so if you want to connect to a database, what do? You go to the POM file and you add your dependencies. Do you want to use Guava? Feel free. You want to use Lombok? Feel free. It's a regular Maven project. So the source code is pretty simple too. Here's the Java default function. So I have an annotation function name. So that's my API /API/hello. That's where that information is coming from. And it's triggered by HTTP. There are other triggers like storage, Cosmos DB, Event Grid, Event Hub, whatever. And you can configure those. For HTTP trigger, you want to set which methods of HTTP you want to support. So I use GET so I can do the quick demo through the browser. Context to get login information, and then the request object is where I create a response. If I don't pass information, 400 and quick stupid information like please pass a name, or 200 HTTP with the response. If I want to respond with a JSON, you just do a dependency of whatever library you prefer. Is it JSON? Just feel free to go to Maven POM file. Okay, so I want to deploy this. Maven Azure function deploy. Now, what you'll see here is that it will use the Azure CLI that is already connected on my environment and simply deploy this into my subscription on Azure. This part takes a while because it's a brand new function app, so it will need to create space in my subscription. But once that is created, deploying subsequent versions, it gets quicker. So let's look at a more interesting example. How do I do CI/CD of a Java Azure function? Because today, you can go, you have your source code on VSTS, and you just want to build and deploy, automate it. So what we do is, there's a Maven, it's a Maven project, and here we have the clean package and Azure Functions package. We archive the directory, because one thing that you will notice, so the work live, one thing you notice here is there's the jar file of my project, but the actual bundle with everything, it's here on the target Azure Functions. What creates this zip file is the Azure deploy target goal on my Maven plugin. Because I don't want to deploy through Maven, what I'm going to do is Azure Functions package, which does not create the zip file, but it creates that folder, and then I zip manually that content. And then I publish that on VSTS. Now I go back to the releases, and I have my release definition that will push this to the cloud. So here's the release 2. Oops. And we can see how it went. So it downloaded the artifact and called the Azure CLI. And the command that I wrote was the Azure CLI function app deployment. Source config, the resource group, the name of this function, and the source, which is the zip file that came from the drop. And this is configured here. So this is the artifact, and this is the task that I have. There you go. Of course, I could use a lot of parameters and make it more dynamic, but for the purpose of the demo, it's very hard to code it. And back to the build of the Spring Boot application, you can see that building an image. It didn't show. It's not showing the log of the Maven build. Okay. But yeah, it will download all the layers from the Docker Hub and then create your Maven project from scratch. So that's it. So we saw microprofile running on Azure Container Instance using microservices and even a fallback. We saw a Spring Boot application with App Insights integrated out of the box, and we saw an Azure function with CI/CD pipeline on VSTS. I hope you enjoyed these demos, and I hope you want to try it out later. All of these demos are easily done on a trial environment that you can get for free for 30 days. But if you do want to know more about Java on Azure and on Pure Cloud Foundry and Red Hat OpenShift, you can check out these links. I ran out of time, but if you have questions, feel free to come to me after this. And don't forget to complete evaluation so you can get prizes. Thank you so much.